Have you ever sat and stared up at the stars and wondered, where did we come from? Let's take a journey like no other, not to a place, but to a time. Join us as we delve deep into the human past and explore our shared human origins. Welcome to the world of paleoanthropology. Hey everyone, fans and family of the world of paleoanthropology. Today is another episode in our most recent amazing lineup of The Story of Us. We have an amazing guest to add to that list today, and I will let her introduce herself.
Hi, I'm Dr. Brenna Hassett.
So, Dr. Brenna Hassett, where where are you currently doing your work right now? Let's start with that. As in, what institute are you from?
It's a fun question. As your listeners may guess from my accent, I do not originally hail from the UK, but I am actually currently in London. I'm just finishing up my contract at University College London. I've been here as a Natural History Museum London Scientific Associate, which I still am, and I'm actually super excited because I'm moving to a brand new job at the University of Central Lancashire, slightly further up north, starting in June. I'm mostly based in the UK, let's say.
Awesome. We have had many great guests from the UK. It definitely seems to be a place that produces or has and hosts some good work on human evolution. So, I, of course, being a responsible host, do some research into my guests before they come on. But, for those who might not know anything about you, why don't you tell us a little bit about your work and why you're interested in it?
Yeah, sure. I think I would say that I'm pretty firmly Team Teeth. In the world of paleoanthropology, there's a lot of specialization. Some people specialize in different species, and some specialize in different sort of parts of, the evidence base that we use. And my particular specialization is teeth. So I actually have a PhD in dental anthropology, which I got from UCL, and that sits on top of my sort of other hobbies as an archaeologist. So I actually graduated from UCLA way back in the day with my anthropology and archaeology degree, and then ended up coming over to the UK, where I started studying teeth. I had originally thought that I was quite interested in a lot of the kind of morbid aspects of archaeology, sort of digging up the dead, which it turns out I am actually super interested in and has made a big part of my career. And the stuff I sort of write and talk about. But what I ended up doing was being at UCL when there was a professor who was super interested in teeth. And I had no idea, I think, coming into my degrees, that basically teeth are like a tiny little fossil in your mouth. They form once and they have this amazing window into everything that happened when they were forming, which is basically your entire childhood. So everything you ate or your mother ate for you, the geology that you grew up around, and even like a minute record of daily activity. And it's all kind of locked into sort of, the fossil in your mouth. So yeah, basically I went very hard on Team Teeth, and a lot of my research, sort of my technical research and stuff, has been on the kind of evidence base, what teeth can tell us. And then the bigger part of my job, obviously, is putting that into context. Like, here's what teeth can tell us. Now, what does that mean for the rest of the world?
Now, before we go on to me asking what can teeth tell us, I'm just curious to know if there are specific species teeth you're interested in, or just teeth on the whole fossil record. I mean, is there a particular area of teeth that you enjoy more than others?
So, oh, you can get so specialist in the world of teeth. Um, there's so many directions to go. So I'm interested in the tissues of teeth. So
Mhm.
I actually look at things very, very close up. My interest is specifically in enamel, which is the hard white part of the tooth, that's on the outside, not the kind of other sort of tissues that make up your living tooth, but the hard white part that sort of really does kind of last and forms a very nice fossil. I mostly look at modern humans. Modern humans have formed the most of my research base. And the nice thing, though, about looking at sort of a specific tissue rather than, say, a specific animal is that, of course, I could look at primate or hominid tooth enamel. But it happens to be that a lot of the questions I think that I'm most interested in happen to be about how our species has sort of lived and died in its most recent incarnation, which is us.
Right, right. Well, that makes perfect sense. So then, what can teeth tell us?
Anything you like, no, okay, maybe not. You do get these like CSI style shows where sort of, they sort of do some magic wizardry with like some holograph computer, and they're like, oh, its favorite color is purple. Teeth are not that good, but they are actually incredibly good at a lot of the stuff that sort of goes into identifying an individual and and to what that individual was doing. So a lot of my interest is in the period of childhood because that's when teeth form. So your teeth start growing before you're even born. Your first baby teeth, the little sort of your front teeth and your bottom teeth, those are growing when your mom's 5 months pregnant. So you're actually starting a record of what sort of nutrients and chemicals and things are getting fed into you, passed through the womb, and then locked up in the tissue of your teeth, even from before you're born. Um, and that's the lovely thing about enamel, is that it actually does absorb all of these amazing chemicals. So we can use isotopic analysis, or the technique of telling which stable isotopes are in a tissue, to look at things like whether you were eating more meat or more plants by looking at different levels of carbon and nitrogen, where you might be in the water cycle, whether you're drinking water that like is at the top of the mountain that just came out of a rain cloud, or whether you're drinking water that's like near the ocean and near the end of the water cycle. If you remember the school diagram, if your water cloud sort of raining over the ocean and all that. Um, by looking at oxygen isotopes. And then some really interesting stuff, of course, with geology, because where you live in the world, you'll have different rocks under you. Different rocks have different amounts of different strontium isotopes, which is, of course, what anthropologists use to determine kind of your locations. You can map where your strontium ratios in your teeth actually say that you were living this specific time in your life. So there's all of this sort of super interesting information about diet, location, mobility, and it really comes together in teeth because of this kind of unique fossil-like situation that teeth have. So if you've ever like broken a bone, which I hope you have not, but uh, um, at least a bone like knits back together, right?
Mhm.
A bone heals. The way bone tissue works is that it sort of chews itself up and spits itself back out, and it refurbishes. So the bone in your body is not the bone you were born with. At best it's like the last 11 years maybe of your life. So that's great, but it's not going to give you a fossil record because it's going to be constantly like rewritten by new stuff you eat, new places you live. A tooth grows once, which, if you think about it, if you chip a tooth, you are going to the dentist and you are paying a small fortune. That's not growing back. Um, yeah, so don't chip a tooth, obviously, is the lesson there. But the same quality that means, it doesn't grow back means that actually it makes it a perfect record for us to look at. And the way that we sort of manage to look at it is essentially aided by the fact that it is also a clock. So inside your tooth is essentially a very high functioning timed record of your development. And that works in sort of two ways. So you can think about, like, we all know that kids like grow their teeth and their teeth fall out. You know, everybody's missing their front teeth in kindergarten or whatever. And so we know, like, okay, there's a regular pattern. So if we see teeth like this, they were probably growing about then. So we can tell kind of the age at which your tooth was growing, and we can guess from there, you know, all right, well, this tooth was growing then. So if we take an isotope sample from this tooth, it's going to tell us about when you were 8, because that's when that was forming, or whatever this sort of happens to be. And that applies to any animal. But the great thing with primates, but humans particularly, is that our bodies have a circadian rhythm, which I guess probably a lot of people have heard of. You know, you may have just disrupted your circadian rhythm by having to get up early to talk to me. But the circadian rhythm, you know, is this 24-hour rhythm. But your cells have this circadian rhythm. And actually, when the little cells that make your teeth, your tooth enamel, these ameloblasts, are growing your tooth enamel and they're laying it down like little snails with glue, they also have little 24-hour pulses. So each day they do their little pulse. And if you give me a laser, well, you could give me a slow Bueller saw and a polisher and you know, some old-fashioned slides, and then you give me a really good microscope, I can actually see those snail tracks in your enamel. I can actually see those 24-hour pulses. So if you have a tooth with 24-hour pulses, you can get a daily record of growth. Or in my case, not growth, because I'm also interested in the stuff that sort of disrupts, you know, what would disrupt growth enough to mess up your teeth. So that's kind of where my research takes me. And of course, what really helps is that all humans who ever lived have essentially a baseline, a day zero that we can count from, because one of the biggest stresses that we can see written in teeth throughout all sort of hominid history is a big dark line going through your tooth when something deeply traumatic happened to you, and it happened to everyone listening, which is birth. So we actually have a sort of 0 point locked inside your teeth. For a lot of adults who are listening, it would be basically in the very tippy tops of your front 2 teeth. A lot of people, like just by normal living, will have slightly worn down where that is. And you could also possibly find it in your first big sort of chunky chewing tooth, should you allow a dental anthropologist to chop it in half and look at it under a microscope, of course. But we basically can use this to do incredibly fine-grained counting. And that actually allows us to open up this whole world of seeing how long different animals' childhoods really were.
Amazing. You know, it truly is stunning how much you can learn and see just from teeth that people, you know, for example, one thing that comes to mind is when Professor Lieberger discovered 2 teeth at, I think, Gladysville, and everyone thought it was such a small discovery, but knowing how much you can learn from teeth, I feel like it was a little more important than maybe thought of at the time.
I'm not sure Professor Berger's ever made a small discovery. He doesn't traffic in those.
Right. So a little physiology question, and if you could make it, you know, a little easier to understand, then I'm probably going to ask it. So these rings on your teeth and these other patterns and chemicals that show up in your teeth, why does this happen to your teeth specifically? Like, is it something that aids us in mastication for some reason? Is it, why does this occur?
Oh, wow. Yeah. So that's kind of an interesting question. So the reason why we've got kind of these structures, I think, is partly a result just of of kind of normal body rhythms. So the kind of clock-like aspects of how our teeth grow is really down to a bunch of sort of other 24-hour rhythms. And there is actually a slightly funny weekly rhythm that shows up in teeth, which can be between 6 to 12 days. But it leaves rings on the outside of our teeth. And that seems to be a kind of superimposed rhythm. Not entirely sure why that is or what causes it and why it's different in some people. That's a question out there for, science still missing some answers. But that clock-like aspect is probably a function of what our bodies are doing otherwise. We're 24-hour animals. We have one big sleep cycle. So that's probably fairly straightforward. In terms of just, holding on to evidence of all of our other stuff, I think that's down to the sort of fossil-like quality that it doesn't regenerate. And of course, there are animals that constantly regenerate their teeth. You can think of sharks, or rodents, for instance. Like if anyone's ever had like a pet rodent, you have to give them chew toys because otherwise their teeth just keep on growing. You have to like constantly make sure they're chewing something. They chew on the bars of their cage and make horrible noise. But for humans, the ideal seems to be that we needed to evolve to have a kind of Swiss Army knife dentition. So rodents do a lot of kind of front-loaded biting. They need to be there. A lot of them are insectivores. So they seem to have teeth that sort of suit that. We've got some sort of sharp biting teeth, incisors. And we've also got some ripping and tearing teeth, like a shark. Those are our canines, the fang teeth. And then we've also got sort of chewing teeth. And we've got sort of more chewing, teeth that are better at slightly chewing, slightly tearing, and then proper chewing. So like a cow or a horse, which also have molars that kind of like, or they basically also have very serious chewing teeth because they're constantly processing grass and stuff. So the reason that humans and all primates have this kind of Swiss Army knife dentition, where we've got piercing teeth, we've got ripping teeth, we've got biting and tearing teeth, we've got chewing teeth, is because of what we eat. We eat anything and everything. So we have the dentition that pretty much matches that, except for the lemurs. The lemurs have a funny little, their front teeth are like a comb, which I think people think is because they need to groom their fabulous tails. And the rest of them, obviously.
That is a great hypothesis, I believe.
I wouldn't say that I'm an expert in lemur teeth, so but they do have a dental comb, so that's something different.
So another thing, if you could explain a little bit, that I recall learning in Bioanth 101, so I'm pretty sure it's pretty important. Dental formulas and how all primates have the same, not primates or...
So hominids all definitely have the same, and most primates have the same. So what you want to think about is that Swiss Army knife. Mm-hmm. So the hilarious thing about humans, and is that so we anthropologists have ways of labeling our teeth. And then there's also another professional group of humans who are very interested in teeth, who make way more money than anthropologists. They're called dentists. And they have a totally different way of referring to teeth. So they'll say, they'll go through the sort of different areas of your mouth. And like I mentioned before, we've got this Swiss Army knife of dentition, and they'll point out each type of tooth. So you've got 2 incisors, which are your piercing front teeth. Then you've got the fang tooth, which is the canine. And then you've got what to a dentist would be your first and second premolar, which is a sort of combo chewing, tearing tooth. And then you've got 3 molars in the back. So your first, second, and then the horrible wisdom tooth, which of course gives everyone total problems. So each quadrant, so each quarter of your mouth, has that formula, and that's what anthropologists refer to as a sort of dental formula, except what a dentist calls your first and second premolar, anthropologists know is your third and fourth, because we evolve from animals that had 4 of those premolar teeth. And it's pretty clear that actually we've lost 1 and 2, and it's 3 and 4 that remain. Functionally, the dentist does not care because no one is ever born with 3 of these premolars anymore. So to them, it doesn't matter. But if you are ever confused why your anthropology textbook does not have the same numbering system as a dentist, it is because anthropologists still remember the 2 we lost.
Never forget.
Exactly.
So, what got you so interested in teeth? Because I mean, I know, there's so many different things you can specialize in. And a lot of people love teeth. And, I can't disagree, but what brought you into it?
I think part of it was being in an institution where there was someone who was already studying teeth and doing cool things. So I think obviously, like when I was being taught, there was more of a focus on teeth than perhaps there would have otherwise been. But I think that teeth offer a really cool insight into a living animal because they're formed while the animal's alive. A lot of the times when you're digging archaeologically or you encounter, a fossil paleoanthropologically, you are looking at the evidence of what happened to that body when it died. I already mentioned earlier how the bones are really only reflecting the last little bit of life. And of course, when we're looking at that animal and its bones, we're looking at, probably the grown-up version. We're looking at, the eventual height and weight it got to. We're looking at the diseases or conditions of the skeleton it had when it was older. But if you want to understand how it lived, it's actually quite nice to have a piece of evidence that's sort of recording all of the stuff that happened when it wasn't dead. Because I think we can all hopefully agree that being dead should not be considered the natural state for our species.
No, I think I'd agree with that one. um, what would you tell someone who wanted to follow in your footsteps and work with teeth and work on, isotopic analysis and things like that? What would you tell them?
I think a lot of the times it's hard to know what you're going to get into. I think in my case, when I started, so in the UK, the master's degree is usually separate from the PhD. So in the States, they tend to be combined. It's a little confusing. Different countries have their own sort of programs. So when I came out of undergraduate, having done a kind of archaeology and anthropology degree, I knew I wanted to do something with bones-ish, probably. I wanted to do something with skeletons. And so when I did my master's, I thought, oh, well, I'll probably find, something interesting to do about like, I don't know, maybe a type of disease or, some medical condition or something like that. But actually, what happened was that I kind of looked at the expertise that was around me. And by the time it came, plan your big research PhD dissertation, it was clear that the sort of advantage that I was going to have was going to be having a supervisor who was super good at what is still a pretty niche field. So there's not that many people who do teeth. And I think that for people who are considering sort of research careers in paleoanthropology, it's so important to have technical skills that are valuable to the discipline. So it used to be that paleoanthropology was a pretty interesting scientific pursuit. You know, we did a lot of visual comparisons. Um, when I worked at the Natural History Museum London, we actually still had bean bags.
Hmm.
So these bean bags were labeled with like 55 cc, 200 cc, and they were full of beans that you could use to pour into a hominid fossil skull to guess how much the cranial capacity was. Like pre-labeled beans.
Right.
Obviously, we don't do that anymore. We have CT scans, we have really intense, complicated imaging software that allows us to reconstruct from like tiny fragments. You brought up Lee Berger's discovery, so Homo naledi, which is the hominid from Rising Star Cave, is a really amazing example of how they're going down into this cave, bringing tiny fossil fragments up and immediately digitizing them. They're 3D scanning them immediately and making that information public super quickly, so that actually, like, the tools of the paleoanthropological trade change. So
Right.
my advice and feeling is that what you want to do is find the cutting edge of whatever it is that you have access and interest to, and try and run it down, see how far you can go. I mean, there's amazing sort of technical leaps that we didn't think were possible 10 years ago, like the sort of 3D digitizing and stuff. That's come on leaps and bounds. Stuff about, modeling, complicated computational modeling, big, papers that look at different, DNA models and stuff. These are all stuff is like, oh yeah, I did not learn that in undergrad because that was not possible. We did not have computers that did that. So I think, it's very hard to plan for what's going to be the next like big leap. But I think if you find that area where you can get support and get people who sort of are slightly going down a rabbit hole, then you can sort of dig your own hole further on, add another burrow.
I think that's a lot of great advice that people can follow. And, it makes it easier when we see someone such as yourself who is just so passionate about what you do. Um, you know, People out there just don't understand how could someone be so interested in teeth of all things. But as anthropologists and any enthusiasts that are watching, as I hope we've made clear at this point, teeth are extremely important. They hold so much information. Now, when we're talking about um, first of all, why don't we talk a little bit about the development of teeth? Because I don't think we've talked about that, and there might be a few people that don't know exactly what happens, the process. So, like you mentioned, when the mother's 5 months pregnant, you've already got some teeth coming in. What is the process of dental? I don't. What's the process?
Dental development. Yeah, no, you were pretty much there. That would be the terminology that we'd use. We'd talk about dental development. So in every sort of mammal species, you've got different responses, but for the species like us, who don't have constantly growing teeth, we've got to come up with a solution to the fact that when we are born, we are quite small, and then we get larger. So the human response to this problem is that we have two sets of teeth. And one of the ways that we sort of use teeth in anthropology is basically as a marker of where you are in age. And that's related to the fact that we've got these two sets of teeth. I think one of my favorite questions was, I think it was very early on, one of the first classes I taught. And one of the students just said, well, why do we have two sets of teeth? And it's like, oh yeah, because that's a very simple question, but it's actually a super like difficult one to answer. And since then, I've thought a lot about how to answer it. And the thing is we have two sets of teeth because we have small teeth when we're small and big teeth when we're big, because it would not work another way. So teeth essentially start forming before you need them. As mammals, we drink milk, and we just need milk for first 6 months of life. We just need milk, and then we start getting our teeth erupting into our mouth. So coming into our mouth. But that set is actually our first set. It's kind of a training wheels set of teeth. There are fewer of them. So we talked a little bit about that dental formula that our primate ancestors gave to us. So we have our two front teeth, our fang tooth, but we only have two chewing teeth when we're babies. So those come in at their little set intervals, and they actually come in at such common times that that's what we can use to tell the age of any fossil or skeleton of a child that we find. So we know that the first incisors, those front teeth, come in at around 6 months. We know that's plus or minus sort of X months. And then we can sort of calculate this incredibly accurate calendar based on sort of what teeth are where. Now, while the baby is having the teeth come into its mouth, this first baby set, which has sort of special characteristics, they're softer, there's not as much hard material in them, so they wear away quicker, and they get a little bit yellower quicker. But the sort of training set, we obviously physically haven't invested in as much, which is good because they're about to fall out. Because the whole time that they were erupting into our mouth, we were actually, just like sharks, growing the second set inside our jaws. So if you ever see an X-ray of like a 5-year-old, it's terrifying. They have teeth everywhere because most of the big white part, the crowns of their adult teeth, are already and waiting there underneath the baby teeth that are starting to get a little bit loose and starting to get ready to fall out. So I don't know if you recall the glorious song, All I Want for Christmas is My Two Front Teeth. The reason that it's absolutely hilarious to make like first graders sing this is because most of them are missing their two front teeth, because those teeth usually fall out somewhere between 5 and 7, and the adult versions take their place. So this sort of overlapping schedule of two sets of teeth is, however, what allows us to keep chewing food, which we need to do to survive, despite the fact that we have grown immensely in size from the time we were 6 months to the time that we are a big, huge 18-year-old, which is allegedly when your last tooth comes in. Not necessarily true. So that your last tooth is your wisdom tooth, which hopefully you and many of your listeners may not have actually experienced, but wisdom teeth are a whole other story. They're actually one of the most interesting examples of modern day human evolution. More and more people seem to be being born without wisdom teeth. So wisdom teeth, do you not have wisdom teeth?
No, not at all.
Oh, congratulations.
I know, right?
Because I had them and they did not fit and it was terrible. So there is a suggestion that as humans have sort of adapted their faces in the last 15,000 years, partially to new foods, partially probably aspects of genetic drift, so different people reproducing and sharing their genes, there seems to be fewer and fewer people born with wisdom teeth. And that's no bad thing because, as a lot of people who do have wisdom teeth know, when we get them, there is often not space and they come in wonky, they come in painful, impacted. You're looking at surgery. You know, it's very rare that our teeth actually all fit in our jaw, which is weird because evolutionarily, eating is super important. So if your teeth are messing up, that's a really bad sign. And the thing that's quite interesting that suggests that it's something that's changing is that, of course, more and more people are being born without, so that we don't have this problem, but that also we don't see a lot of problems from kind of the period before the invention of agriculture and dietary shifts that came around 15,000 years ago to slightly different types of foods. And people have suggested that actually it's not our poor teeth that are at fault, it's our faces, that our faces themselves are actually shrinking. We're not eating quite the same diet that we used to. A tough, rugged, sort of fibrous diet that would make us chew and chew and chew and then chew some more, building up our jaws and our muscles throughout our lives, making us have really big, fat jaws. Big, fat jaws, of course, that could fit as many teeth as you like. If we're not giving our jaws that space, if we're not sort of forming big, huge jaws, then we might actually be forming jaws that never even give that third little molar the space to form. So if it's not getting the space to form, the little bud, like the little bud is not going to happen. It's just going to go missing, and you're going to have teeth that hopefully are in nice alignment. They're not being knocked out of place by this horrible wisdom tooth that's, you know, knocking everything sideways and squishing you and causing pain and being terrible. So it's a really interesting thing that it looks like, you know, some of the ways we live do seem to actually affect, you know, our actual physical, something that we would have thought in the past was totally immeasurable. I mean, imagine the poor anthropologists who were so sad about losing 3 molars, 1 and 2, and now we're losing another molar. At least we don't have to change the numbering system, though. That's good. It's the last one.
Oh, that's funny. What do you think is the most important single thing we can learn from teeth?
Well, I think, I could probably come up with like a million things, but I think the thing that I got really, really interested in is this kind of use of teeth as a clock. So a lot of my work has been looking at how teeth show us when growth went wrong. I've always been interested in child health. So your teeth will react to any big insult to your body. So like especially fevers and stuff like that. So I've always been interested in kind of how teeth can tell us when and how children got fevers in the past, because that tells us about diseases. It can tell us about, what times of life were most dangerous for our species to like get past in order to survive. And I think that's really interesting still. But one of the things that I've been thinking about a lot recently and sort of ended up being kind of the point of my latest book is that teeth show us how fast we grow. And I think that's the really interesting thing evolutionarily about humans, is that if we use that clock that's locked into our teeth, that 0-day moment from the line that forms at birth, and then we start doing our 24-hour counts, and we sort of go through all your teeth, and we clock up basically how many days it takes to make you. We can look at our species and, oh my God, we're children forever. Great. We knew that. But we can actually see that is an evolutionary path that we seem to be choosing. So if we look at primates, they grow much faster than we do. They get through their childhood phase much faster than we do. And then we can go back in time and look at hominid ancestors and sort of cousins and close relations and say, actually, yeah, these guys are growing much faster than we are. So a slow childhood seems to be something that we're actually selecting for. And we know that in primates, for instance, that the timing of when different teeth are ready is really tied to a lot of life events. So your first chewing tooth in your molar, your adult one when it comes out, is usually when you get when you transition from breastfeeding to kind of full independent, to eating sort of other food. We know that the sort of the second molar seems to be when you're sort of able to just about forage for yourself. And then the third molar usually comes in other primates at the point of sexual maturity. So when you're about ready to reproduce. So we actually know that there are kind of timings associated with teeth. And when we actually take the days and count them out in our species, we can definitely tell, we are pushing the limits. We are extending our physical childhood. And that's something that we seem to have evolved to do. So I think it's such a fascinating idea that as a species, we are evolving these huge long childhoods, and we can see it actually evidenced in the teeth.
And, being able to see and understand so much from the teeth, I think is just so unique amongst things in the field. And it's no shock or surprise to me why someone such as yourself is just so passionate about it. It really does sound like very exciting content. I think this might be our final question. What is the most shocking thing you have learned in your work?
Oh, I think, it's usually either something about primates, because primates are just so weird, or so actually when I was researching, so my recent book is about the evolution of human childhood, so growing up human, evolution of childhood. So I had to go through all of the bits that make a child, from like mating systems through pregnancy, through gestation, just pregnancy, to birth, and all of this stuff. And like there's just a ton of stuff that isn't like normally in my field, but I had to learn about because it's part of the process that I was writing about. So for instance, I had not realized that the placenta, which is the organ that makes mammals, it's the little organ that we as mammals have that allow us to basically siphon food from mom into a new animal. It's the mobile eggshell. I did not realize that the entire reason we have that is that a couple 100 million years ago, some little animal captured a bit of RNA virus, and it's that DNA that we use to code for this insane organ that makes our weird lives possible. Like there would be no mammals if we hadn't basically adopted virus DNA. And it's like, oh, thanks, I guess.
That is shocking, yeah.
Yeah. So a lot of it was sort of also learned that marmosets can have chimeric babies where they have more than one dad and that like the DNA mixes. Marmosets are
I
weird.
didn't know that, but that is very crazy.
Yeah.
Yeah.
Yeah. No, marmosets are definitely, I love marmosets actually. Not only are they super cute, but they're another pair bonded animal. And the dads do all the carrying, and I love that for them. They're very cute.
That's adorable. Well, I just want to, is there anything that you would like to finish with before we start our closing remarks?
No, I hope that my rampant cheerleading for Team Teeth has convinced some people that there is some interesting stuff in there. Please please record your teeth appropriately when you find them in the field.
Well, I just want to thank you again so much for coming on the show. It's been an absolute pleasure. I have learned so much. I hope that our viewers have learned just as much as well. And I just want to thank you again for coming on. I really appreciate it.
Absolutely.
All right. Make sure everyone to hit that subscribe button and make sure you hit notifications to turn them on so you don't miss any future videos. Thank you everyone so much, and we'll see you next time. Thank you for watching this episode of The Story of Us, where we interview and talk to researchers who are doing the work in the field. We hope that you learned something, as there's always more to learn, and please stay tuned to the next episode, which will be airing in a couple of weeks. Be sure to check out our merch store, and, it never hurts to leave a tip. So, thank you for learning, and see you next time.